Hello, my name is Jacob Wood. The purpose of this video is to test the ultrasonic sensing block within the Smart Luggage design project. The purpose of this block is to eventually be integrated within the system as a means of object detection. To test this block, I will be following the procedures defined within this block description document, starting with the list of the interfaces to be tested. We'll start by testing the DC power interfaces from the microcontroller to the actual ultrasonic sensor block itself. I will also be testing the signals between the ultrasonic sensing block and the controlling microcontroller. And lastly, I will also be testing some interface requirements between the ultrasonic sensing block and the environment itself. To test this block, I will follow this wiring diagram here. The only exception is to test the 5.2 volt maximum supply voltage. I will be using a power supply. And here you can see some of the actual testing procedures and testing programs as well. First, I will verify the input voltage range and nominal current. So to do so, we will just use a power supply and set it at the 5.2 maximum working input voltage and connect a digital multimeter in series and run our testing script to take measurements of distances. So if we read the output of the series digital multimeter for 30 seconds, we can see that the nominal current is around 3 milliamps at the maximum input of 5.2 volts. To test the minimum trigger pulse duration, we have placed a solid object within 2 centimeters of the receiver and transmitter, and we will probe the trigger line. We've used the same 5.2 voltage source, and we'll run the same testing program on the Raspberry Pi. On the oscilloscope, probing the trigger line, we will try to stop this, and as you can see, this is well within the 10 microsecond limit. To test the minimum echo duration, I have placed a solid object at the 5 centimeter threshold and probed the echo line with the oscilloscope. Again, I will provide the 5.2 voltage source to VCC, and we will run the same testing program on the Raspberry Pi. Using the oscilloscope, I'll try to take a single snapshot measurement of this echo line, and we will see if it is within 300 microseconds. So here's the snapshot, and you can see it's right at 300 microseconds, so everything below 5 centimeters will pass. To measure the maximum measured distance and corresponding echo duration, I have placed a solid object about 200 centimeters from the sensor and probed the echo line, again providing 5.2 volts, and using the same testing script, we will check the output of the oscilloscope and try to take a single snapshot. Here you can see that the returned echo pulse is within the 12 millisecond listed limit. To test the absolute minimum measured distance of the module, I've placed an object within 2 centimeters of the sensor, provided 5.2 volts, and run the same testing script. You can see, judging by the placement of the ruler, that the object is within 2 centimeters, and that's what we're getting from our output of our testing script as well. Just to confirm this on the oscilloscope, you see that this returned echo duration also falls within the minimum listed 300 microseconds. In order to test the ultrasonic properties of this measurement module, I will take advantage of the 40 kilohertz receiver and transmitter located on the module itself. Here you can see the module as it is wired up. If we take one of these individual ultrasonic sensing modules and look at it closely, you can see the transmitter on the left, receiver on the right. And on the back we can measure this R17 resistor hooked up directly to the receiver. Now if we supply the same 5.2 voltage source using the same testing program, we can take a single snapshot of the output waveform of the R17 resistor connected to that receiver. So if we look at this oscilloscope, using the fact that these receivers only pick up 40 kilohertz signals, we can deduce that this in fact is a 40 kilohertz signal and therefore ultrasonic. To test that the ultrasonic module is water resistant up to about 10 milliliters of water application, we'll fill this spray bottle up to about 10 or 15 milliliters to ensure that about 10 is being applied to the module. I'll then speed up the process of spraying the module, and immediately after application I will plug the module back into the testing circuit, place a solid object about 10 centimeters away from the measuring unit, and run our same testing program while supplying 5.2 volts to the module. And you can see as I slide the solid object further and further away from the measuring unit, it records accurately.